Welcome back, ladies and gentlemen. In this video, our goal is to find an equation of an ellipse given some information regarding the foci of the ellipse and the minor axis. And then we're going to go ahead and just kind of give you a quick representation of how you could graph this on your graphing calculator. But first and foremost, we are given that the focus is at 0, -3, and 0, 3, and it has a minor axis length of 4. Well, the question that you first have to kind of ask yourself is where is the center going to be? Now, I know for a fact the center is going to be at 0, 0. Well, how the heck could you know that? Well, you know that because that both of the x-coordinates are 0 for the focus, and they are both the distance of 3 away. And so that means that they are on the y-axis, and they are both the same distance of 3 away from the origin. And so if I'm sketching this out, I have a point at 0, 3 and a point at 0, -3. Halfway in between is at 0, 0 for the origin. And so this also kind of helps us identify that this is going to end up being a vertically represented ellipse, because the focus is on a vertical axis. All right, so let's continue on. It says whose minor axis has a length of 4. So that means the entire distance of the minor axis, so maybe from here to here, is a length of 4. What does that tell us? Well, that tells us there's 2 to the left and 2 to the right. That means that you have a point at 2, 0 here and a point at -2, 0 here. The last thing we need to find is, okay, really where are the vertices going to end up being in this case? Well, we'll get there. We will get there. Okay, so the focus on the y-axis, right, that has that length of c. And like I said, we just did that semi-minor axis of b, quote unquote. So this is our little length of c right in here. This is little c, and this is little b. All right, has a length of 2. Now, if we think about the idea of what we have, we are really trying to find out what that value of c is going to be in this case here. Or sorry, the value of a is going to be here. So I can find out what the distance from the origin to the vertices are going to be. So I know that a squared will equal b squared plus c squared thanks to our ellipsis Pythagorean identity. So a squared is unknown, the distance from the center to the vertices. But I do know b, 2 squared. I do know c, 3 squared. So a squared is going to be 4 plus 9. And then a squared would equal 13. So that means the distance from the center to the vertices are going to be square root of 13, respectively. And so then what we're looking at is that we have a point, maybe somewhere around here, that is going to be 0 square root of 13, and then a point down here that is going to be 0 negative square root of 13, and those are going to be the two vertices for our ellipse. Okay, so now as we're kind of going through this, let's look at what the actual equation is going to look like. So I know that it's represented vertically, so usually we put the y first if it's represented vertically. And then remember, you put the larger, right, the larger distance, to the larger distance. So you get the square root of 13 squared plus x squared over the smaller distance. So in this case, you're going to end up having that minor axis, which is 2 squared, all set equal to 1. Well, when you simplify this guy out, it becomes y squared over 13 plus x squared over 4, all set equal to 1. So this guy right here would be your standard form of an equation. Well, what if you wanted to graph this on your graphing calculator? So what I want to do is I want to go ahead and just take a look at what would you do to actually input this into the calculator. Now, I'm not going to show you on the calculator right now, but I'm going to solve for it, and then you could just put these into your y equals equations. So when you're doing these, you want to basically solve for y. And so if you kind of go ahead and take y squared over 13 plus x squared over 4 equals 1 and solve for y. I'm going to subtract over x squared over 4, and then I'm going to multiply by 13, and then square root both sides. And so ultimately what we end up getting are two separate square root equations. And so then when you're putting it into your calculator, you would say y sub 1 is going to be the positive, and then y sub 2 would be the negative. And that's just going to turn the parabola-looking shape over. And then that's how you would see your ellipse. And of course, you got the adjust